Let's go ahead and talk about solving by factoring. So we learned how to factor both when our A term was a 1 and when it wasn't a 1, and we had to use guess and check. So we are going to use both methods to solve by factoring. I wanted to make a note here that when I say solve, sometimes there are several words that are used interchangeably. So solving means finding the zeros, the x-intercepts, the solutions, or the roots. So all of those particular terms might be used, and they mean the same thing. It basically means that our y value is 0, and we're seeing where the quadratic, the parabola, crosses the x-axis. And so solving by factoring can be used when the equation can be easily factored. Let's look at this first one. And the first thing that I notice is this is not in standard form for me to be able to factor. So I want to go ahead and move it to standard form. X squared's in a good place, but the 14x and the negative 40 need to be moved. If I subtract 14x from both sides, I will have 14x on the left. And if I add 40 to both sides, I'll have 40 on the left. On the right-hand side, I'm just going to have a 0. And again, this is standard form. The next thing I want to do is factor, and this does have an a equal to 1. So I know that x goes in the front of each of these. And if I think about factors that multiply to 40 but add to be a negative 14, I'm going to need two negative numbers. One of those is a negative 10 and one is a negative 4. And so this is my factored form. The next thing that I want to do is use an algebra property called the zero product property. And that basically says if we have two things that multiply together to equal 0, then one of those two things has to be 0, because that's the only way you can get two things to multiply and be 0 is if one of the things that you're starting with is 0. So using the zero product property, I'm going to abbreviate that, zero product property, we can say that either x minus 10 has to be 0 or x minus 4 has to be 0. One of those two things has to be true. If x minus 10 is equal to 0, then x is equal to 10. If x minus 4 is equal to 0, then adding 4 to both sides gives me that x is equal to 4. Let's look at our next example, 2x squared minus x is equal to 6. I'm going to use these same descriptions to describe what I'm doing in this example. So on my first line, I want to get this into standard form. 2x squared minus x minus 6 is equal to 0. I subtracted 6 from both sides. Now factoring, I need two things that multiply in the front to be a 2x squared. So that's going to be a 2x and an x. In the back, I am going to have to do some guess and check. And as I run through factors of 6, I have 1 and 6, 2 and 3. And if you play with those long enough, what you're going to come up with is that you need a positive 3 and a negative 2. Remember, we're using our guess and check method. This is the set of factors that works. A positive 3 and a negative 4 are going to give me the negative 1x that I need. Moving on to my next step, my zero product property, which is down a line here, is going to say that 2x plus 3 is equal to 0, or x minus 2 is equal to 0. Let's go ahead and solve this first one first. It's going to be pretty easy. I would add 2 to both sides and get that x is equal to a positive 2. The next one, you might need to write an intermediate step. So I'll go ahead and do that here. If I move the 3 over to the right by subtracting it from both sides, I get 2x equals negative 3. And then dividing each side by 2, I get that x is equal to negative 3 over 2. And that's my final answer. I'd like for you to try problem number 6 and then come back here and see how you did. The first thing I notice is that I need to get this into standard form, so I'm going to subtract 6 from both sides. Then I need to factor, and this has an a value greater than 1, so I'm going to need to use guess and check. I can put 3x and x in the front, but then I need to try combinations of 1 and 6 with positives and negatives and potentially switching the 1 and 6 to different locations. And then 2 and 3, positives, negatives, and switching those around. And the factors that I found that worked was a positive 2 and a negative 3, because 2 times x gives me a 2x, and 3 times negative 3 gives me a negative 9. Negative 9 plus 2 is going to give me the negative 7 that I need. Then I use the zero product property and set each of my equations equal to 0, or my expressions. So 3x plus 2 equals 0, and x minus 3 equals 0. This gives me a value of x equals 3. And then with an intermediate step of 3x equals negative 2, when you subtract 2 from both sides, finally dividing by 3 gives me that x is equal to negative 2 over 3.